in many various capacities for uh, almost 20 years now. Please don't calculate how old I am. Um, what I did, I started off on the International Space Station. And you can see from the International Space Station, it has these big, huge wings, or we call arrays. The solar arrays are what are gaining that electricity so that we have our vehicle and can operate it, run the fans, run the propulsion, and all the things that we need. And so all of these vehicles that you see up here on the screen are types of electric vehicles that I'm super excited to be here today. Now, I show you this just as a preview for electric vehicles, but what's the coolest thing is what you all are going to do today. And I'm so excited to see the vehicles that you all are going to make. Maybe you're going to be making the next Mars rover, right? And of course, I don't want to leave out its friend up there on Mars, Ingenuity, the helicopter. Well, today we're going to focus on the left-hand side by making electric vehicles, whether you're making one for here on Earth or up on Mars or any other planet, it's all the same basics. And so that's what we're going to talk about real quick today, and then get you started building your own. All right, so how are we going to do that? Real quick, what it's going to look like, and all of yours are going to be unique. And that's what I love about engineering. You get to figure out in your brain how you want it to work and make that work. So teachers, we're not going to hand out any kits right now. We're going to wait and hand out the kits after the presentation. But you can see here in our kits, there will be all kinds of materials that you can decide how you're going to build your electric vehicles. But before we begin, we kind of need to know how they work, right? So in the chat, please drop off in your chat what makes an electric vehicle better. Can you think of any advantages to having electric vehicles? Does anyone think of any? I'll give you a minute here because I know you guys are out there and you're smart and you know it. Oh, yeah. So Mr. Richardson's class is rocking it this morning. Yeah, you're saying batteries. Battery strength is so important in these cars, you guys. And you know what? I'm inviting each and every one of you in some way to find what you enjoy about this lab today, because we need smart, good engineers and marketers and all kinds of people across the industries to help bring our country forward. And so someone just said less fossil fuels. Oh man, good. Less emissions, no gas use. Oh, you guys, you're hitting it right on the head. The torque. Oh yeah. The economics. It's cheaper to charge. We are going to hit all of these here in just a second. This is so good. All right. So on the left, you can see what we call an ICE, an internal combustion engine, or what we normally call like gas engines. And you can see there's a lot of parts. What do you notice about the right-hand side, the electric vehicles? What do you see? You're probably noticing there's fewer parts, right? And guess what? That's a really good thing for us, because fewer parts means fewer things that can break. And in our case, that's a huge advantage for electric vehicles. But you also named quite a few more, and we're going to get to those as well. So electric vehicles, we're basically going to have our batteries, and they are going to power our motors. And you can see the motors over here. And we're going to walk through this step by step. You'll get to decide which type of car you want to build. Like, what propulsion do you want? And that is, I'm going to find really cool. All right. So the other advantage, and I don't think well, someone said no brakes. So it's kind of along this line. Another huge advantage is regenerative braking. So in a typical fuel car, we brake when we want to slow down, right? Everyone's used to that in your cars. However, with an electric vehicle, we can use what we call regenerative braking. So converting that extra energy that we're stopping the vehicle with, convert that to electricity to charge our batteries as we're slowing down. And then we have more juice to go ahead and accelerate back up when it's time to go from our red light to a green light. And so regenerative braking is also a really great use of the energy that we do have in the system there. As one of your classes already mentioned, this was so great. Like, how much does it cost? Yeah. So these days, right, to buy an electric vehicle is more expensive than the average car. Although it's really great that over the years it's coming down and down, and it's becoming more affordable. And you know why? It's because people like you get into the industry and they start saying, how can I make this better? Or what if we change this? And they're inspiring our engineering processes and making things better and better. So I think this is even going to drive down the cost of electric vehicles in the future. On the left, you can see what we call the EV efficiency or the cost of electricity. And then on the right, you can see the fuel economy of a gas powered or like our typical older cars, right? So a cost per gallon, and I don't know about you guys, but 250 sounds pretty darn good to me. You can see how far we can typically go on that. And it's about 22 miles. And you can see over here, we're going to compare that. Like, it's hard to compare apples to oranges, right? But we're going to compare how far we can go per dollar, right? And so in this case, we're going to study how much kilowatt hours we go into our EV efficiency. And so for every dollar that we charge our vehicle, how far can we go? And I want you to take a look at this. What do you notice on the screen? Which car goes further? The one that's electrically charged per dollar or the one that's the gas, fully gas? So I know you're probably rocking that one already. So yeah, it's that one on the left here. You can see the efficiency is so much greater that we can go so much farther on $1 for our electric vehicles. And that's another huge advantage. So what are some disadvantages? Does anyone think of any disadvantages? I can think of one. Well, I can think of a couple, but there's two that come to my mind. One, it takes a little bit longer to fuel up, right? So we want to cross the country and you want to charge your vehicle. Well, you have to kind of plan your route. What's really good is our previous administration had put in something like $5 billion in order to put charging stations in more and more locations. Yeah. Okay. Another disadvantage from Dr. Milo's class says initial costs are higher. You hit the nail on the head there. That is right. They are. It's more expensive to buy those cars, but over the long run, you can see that just being able to drive it multiple more miles than you could any other car. Unhealthy electromagnetic radiation for passengers. That's an interesting one. I would like to know more studies about that. I love learning about like the biomedical effects of all of our things, our phones and other electronics as well. Lithium extraction. Oh my goodness, these are such great answers. So as you imagine trying to charge your vehicle, we have different charging stations across the country now. And I feel like as our government moves more and more towards renewable sources to not be depleting our atmosphere and our resources that are in our earth, I think this will become even more and more prevalent in all of our societies. So I don't know about you, but I am getting ready to build. So what does that mean, right? Your guys are going to build your own electric vehicle. You notice here that this car that we're looking at is a propeller on the back. So you could call that its propulsion system, right? It's the driving force that's going to move that car forward. And I bet you all are thinking, for every action, there is an equal and opposite. I know I heard it. Reaction, right? So that force backwards is going to push you forward, just like a spacecraft. So as you get designing, we're really going to focus on the engineering design wheel up here, this process that we go through time and time again. We learn a little bit about the system, which you just did. You learned about the parts. You learned that it's fewer parts and all of that. We've talked a little bit about our design. I challenge you, as you get ready to build your car, you might want to lay it out on paper first. You might want to draw it out and know exactly what you're trying to fit together, because that can be really important. You'll start building. As you build, I bet you're going to find things that don't work quite right, and you're going to test it, and you're going to find those things out. And then you're going to deploy it. Guess what, guys? You get to run your cars in the hallway and test it against your classmates. So that you'll notice there's going to be some lines, blue and green. You'll find those pairs and you'll be testing your cars in the hallway for that. So what does that look like, right? We have our kits. And so I'm going to run and I'm going to show you real quick here my other video feed. And I just have to turn off my background so you can see it. So give me 1 second. I apologize for that. Okay, so what does that mean? What are you guys getting in your kits, right? So you should be getting some popsicle sticks, some pieces of cardboard. You probably all can figure out what the wheels are for. But then you have these other things. So this is our motor. And just like we talked about, our motor is the heart of our electric vehicle. It is the electric propulsion that changes our direction. It moves us forward, back. It's what makes us go. So this is our motor. You'll notice in this motor here, there are going to be these leads. It's very important to connect when you're making your circuit, metal on metal. So how do we do that, right? The word circuit comes from the word or circle. And so you're going to be taking your battery pack, which looks like this. Notice there's a little pull tab there. I know you all know what to do with that. And you're going to be making a circle by connecting your wires. And you notice here, let me bring it back in a little bit. We've got our circle. So you'll be connecting your circle. Again, remember, metal on metal is the key for electricity to flow. As soon as you do that, this motor right here is going to be turning. So then the question becomes, what 3 types do you want? Do you want to create a geared car where your gears have to fit together perfectly in order to drive the other one?
Hey,
So
Betsy,
that could be one type of car.
sorry to hop in, Betsy. We can see your slide only.
Oh, good. That's perfect. In fact, so on the slide, you'll see the gears over here. Um, the next one you can look at is doing pulleys. And are you seeing my video as well? Like
No,
my hands?
no.
You're not seeing my hands? Interesting. All right, 1 second. Let me just stop sharing completely. Thank you for letting me know. All right, now do you see my hands?
No, your camera's off. Let me
Are you
spotlight.
seeing it now?
There we go. Yep.
Oh, you all, thank you so much for your patience there. All right, so here we go. We've got our wheels over here. We've got our propulsion systems. So are we going to do a propeller? Are we going to be doing a pulley system or are we going to do gears? Gears must fit together, exactly together with their teeth in order to rotate and make those things turn. So here's your motor. I'm going to go ahead and show that one more time since you didn't see my hands before. You're going to be connecting your motor and making sure these leads here, that metal on metal occurs, and make sure your electricity flows in a circle from your battery pack to your motor. The second you connect that motor to that battery pack, you're going to notice this start turning. And that's where you get to decide, what do I want to turn on that? Do I want a pulley system? And notice pulley systems, they have these belts. What do you think might be hard about a pulley system? What do you think? You see that? So if you're saying tension, that is the most important thing, right? So adjusting the tension and the placement of these can really be tricky with a pulley system. So keep that in mind. Then there is the geared system. So again, making sure those gears fit directly together. And we're going to talk real quick about what that means. You have a couple axles over here. Notice those axles. And we've got some straws. Can anyone type in the chat? What do you think we do with straws? Anybody? Why would we need a straw? Think about how you're going to attach your wheels. And if I attached the metal straight to my car, what might happen if I attach that? Yeah, it's probably going to get stuck, right? It won't turn. And that's the whole point of our car. We want it to turn and we want it to turn with the least amount of friction. And so what we will do is stick our axles through the straws and then attach the straw so that we can freely move. All right, so those are kind of your parts. You get to choose as the engineer for your system, which type do you want? Do you want one with a propeller? Do you want the gear or do you want the pulley system? All right, I'm going to switch on back over real quick here to the presentation and finish on out so that you get started here shortly. All right, like I said, you've got your system here. You're going to pick your motor, get that working, choose which force you're going to use to drive your car. Attach your wheels and make your base and put it all together. You've got this. I know it. All right, looking at the screen, you can see if you're using the gear system, we have something called mechanical advantage. And mechanical advantage is using the different sizes of our gears in this case. And you watch what happens when that first gear is turning. It goes around a lot of times, right? And if you'll notice, the outer one doesn't have to work as hard, right? And we call that mechanical advantage. So as the little one's going really fast, the outer one's still moving and it's doing one rotation to every 7. So I want you to study that. If you're using your geared system, check that out and see how that's going. Likewise, mechanical advantage and pulleys. It's a very similar situation, except they're not right on top of each other with their teeth. You'll notice that they're spread out by the tension of the belts that go on the pulleys. And so that will be really important as well. As you look at the screen, what do you think might be hard about a pulley system and how would you have to design it? One advantage that you're seeing in some of these electric vehicles is that low weight. It's towards the bottom of the vehicle that helps it keep it really stable. And guess what? You guys want a stable car and you want a really fast car, I'm guessing. Here are a couple ideas to get you started. You can see here on the left is a propelled version. Down here, it looks like it's a geared version. If you've got pieces of things laying around, you can make that the base of your car. In fact, I took a 3D printed castle and just put it on wheels with a motor and it could go. So be creative. We are here to see how creative you can be for the aesthetics, how fast you can be, and how well you all work in teams. In fact, that's the challenge today. We are going to be racing our vehicles to see whose is the fastest, whose has the most aesthetic appeal, and what is that teamwork. As I mentioned earlier, in your hallway, you will see pairs of blue and green tape. You will be testing your cars in the hallways at these distances. And each classroom will be determining who is the fastest winner for that classroom, which will race against all the other winners to find the ultimate winner of your school. And I know that could be you. And I'm so excited to see everything that you get to design today. So my question is, are you ready? I thought so. So what will happen next is you will go to your next classroom and you will get your kits and we will start the design process. I want to wish you all good luck. I cannot wait to see your designs. Thank you so much.